We're continuing with the supplemental review questions for test number 4. I'm picking up with number 7, and it says Alexander was poisoned with 10 micrograms of the radioactive substance polonium-210. Since radioactive decay follows a compounded continuously model, we can determine the amount of substance left in Alexander's body at any given time. If polonium-210 has a decay rate of 0.502%, then determine the amount of polonium-210 left in his body after 105 days. Provide 3 decimals and a label in your answer. Okay, again, be very careful with this last statement. You want to make sure that you round your answer to 3 decimal places, and the idea of giving it a label means it wants you to give the units. In this case, the units, the amount of polonium is going to be in micrograms. It also helps us out here in this problem because it kind of refers you to the formula you need, because it says it follows a compounded continuous model. So the compounded continuous model is A equals P times E to the RT. And remember, if you're thinking about what these things represent, okay, remember that A is the ending value, P is the initial amount, R is the rate of decay, and T is the time. So if I'm reading this, it says we can determine the amount left at any given time that he was originally poisoned with 10 micrograms. So the initial amount was 10. It tells us it has a decay rate of 0.502%. Again, though, guys, remember that's a percentage, and we want to change it to a decimal. To change it to a decimal, we take 0.502 and divide it by 100, which would be 0.00502. And then our time in this case is 105 days. Okay? So again, we're looking for A here, and it's kind of a straight substitution problem. We're going to plug the numbers in to the formula. So we would have 10 times E to the 0.00502 times 105 days. Now again, I can baby step this a little bit because I would have 10 times E, and I want to go ahead and multiply together, okay, 0.00502 times 105 days, okay, which is 0.5271. So we would have 10 times E raised to the 0.5271. Okay, so then it becomes, again, really a straight calculator problem, because I can type 10 times, and to get E, you press the blue second button and LN, and the little E appears. We put the exponent, 0.5271. I'm going to close the parentheses, hit enter, and I get 16.940. So again, it wants 3 decimal places, so I'm going to write 16.940, and again, it also wants the units. So we have 16.490. You do need to put the 0 in there, and it's micrograms. Okay? As your units or as the label. Again, it's pretty much a plug and chug problem if you have that formula handy, because it even tells you to use that particular formula. All right, continuing on to question 8, it says Ricky Bobby wants to buy a new automobile for $58,000 in 4 years. How much money must Ricky's original investment be if he makes a single deposit into an account with monthly compounding and an annual interest rate of 4.70% in order to reach his goal? Again, round your answer to the nearest cent and provide only the numerical value for your answer, which again means when you write your answer, they do not want you to put $sign and they want it rounded to the nearest tenth. Now, you got to be careful. Read the problem carefully because this one says, I have it highlighted and in red. It says a single deposit. We're not looking at making a deposit monthly. So this is really just a straight, flat out interest problem. So we're going to use A equals P times 1 plus R divided by N to the NT power. Now, in this case, though, let's think about what we know. Okay, it tells us that in the end, he wants to buy the car, which is going to cost him $58,000. He's going to wait 4 years to buy it, and he's going to have an account that is compounded monthly at a rate of 4.70%. Again, remember to change that to a decimal by dividing 4.70 by 100, okay, which would give you 0.0470. So what I'm looking for here is actually the principal. I'm looking for P. Okay, but again, it becomes a chug and plug problem. So I have 58,000 equals P times 1 plus 0.0470 divided by 12 raised to the 12 times 4 power. And again, at that point, I'm going to definitely get out my calculator. Remember to follow order of operations. So we're going to do the division inside the parentheses first. 0.0470 divided by 12. Then we add 1. And then we raise it to 12 times 4. I can do that in my head. That's 48 power. So I have at this point 58,000 equals P times 1.206. Okay, 1.206, that big long decimal. So then what I want to do on my calculator, I'm going to do 58,000 divided by that big long decimal number. Okay, so P would be $48,077.30. Okay, so P equals $48,077.30. Okay, $48,077.30. Again, when you enter it into your calculator, do not put the $sign and round it to the nearest cent or the nearest penny. So you want 2 decimal places. All right, one more. It says if $5,000 is invested in a savings account with an annual interest rate of 7% compounded quarterly, how long will it take for the amount to grow to $8,000? So here again, this is an interest problem. It doesn't talk about making payments, so it's straight interest. So we're using our interest formula. But this time, I believe we're going to be looking for T because it asks us how long. Okay, but let's see what we've got. Okay, we started with $5,000 invested into the savings account, 7% interest. Again, remember to change that to a decimal. You'd have 7 divided by 100 or 0.07. It's going to be compounded quarterly, so that's 4 times per year. And we want to end up with $8,000. So in this case, we're looking for T. You're using the same formula, you're just manipulating it for a different variable. Okay, so we have $8,000 equals 5,000 that we started with initially, 1 plus 0.07 divided by 4 raised to the 4t power. Now here again, I'm actually trying to solve for 4t or for t. So the first thing I want to do is to get rid of that multiplication by 5,000. So I'm going to divide both sides by 5,000. So we can use our calculator. 8,000 divided by 5,000 is 1.6. So I have 1.6 equals 1 plus 0.07 divided by 4 to the 4t power. Okay, so then I got to do a little bit of work there on the right side. I'm going to work within the parentheses. So I have 0.07 divided by 4 plus 1. Okay, so I have 1.0175. Okay, so we have, let's see, 1.6 equals 1.0175 to the 4t. Okay, I believe that was right. Let me double check my number. 0175. Okay, now we got the exponent, and so I need to kind of bring that, get rid of the exponent. So I'm going to take the log of both sides, but I'm going to use a base of this 1.0175. So I'm going to do log of 1.0175 of 1.6 equals log of 1.0175 of 1.0175 to the 4t power. Okay, now, again, what that does for us is here I have log and an exponent, so I have 4t equals the log of 1.0175 of 1.6. And then what I want to do is divide both sides by 4, and I'm going to have to do some calculator work. Okay, so I have t equals. Now to deal with this piece in the numerator, that log, I'm going to use the change of base formula. So off to the side, I'm going to come over here to the side and do the change of base. So I'd have log of 1.6 divided by the log of 1.0175. So let's see what we get. Okay, so we would have the log of 1.6, close the parentheses, divide by log of 1.0175, close up the parentheses, enter, and I get 27.09, and then I'm going to divide that by 4, and I get 6.77. Okay, how many decimals did it want us to have? Let's see. It didn't say, did it? Okay, it doesn't say. So we get roughly 6.77 years. So we're close to 7 years if we rounded it to a whole number. If you want to try to figure it in months, you're looking at a little bit more than 6 years and 9 months. Okay, but there's your answer.